Hello guys, welcome to Amazing Engineering, and today in this MatLab tutorial we will see the workspace and the Jacobian matrix of the robot. About the workspace, it is made up by the position reached by the end effector during robot motion. In order to represent the whole motion of the robot, we need to know the range values of its joints that can be read by robot datasheet. In this case, we are considering a robot made up by 5 rotary joints, as we did in the previous video. So the range values are all represented by angular values. The conv variable is used to convert the angular values from degrees to radiant, which is the units of measure used by MATLAB for the angular values. In order to represent the workspace, we can use several force cycles, whose variables are the joint variables. In this case, we are considering the first, second and third joints of the robot. And after that, we have to define the transformation matrix between the links. This matrix can be represented using the command trotz, which allow to define an homogeneous rotation matrix along the z-axis, transl, which define an homogeneous translation matrix, and trotx, which define an homogeneous rotation matrix along the x-axis. Their components represent the Denavit and Attenberg parameters of the robot. For example, if we focus on the transformation matrix T01, so the transformation matrix between the first link and the basement, the component of trotz is the joint variable of the first link. The components of transl are the Denavit and Attenberg parameters A and alpha, A and D. So we have a translation along the x-axis equal to 350 and a translation along the z-axis equal to 675, and at least the component of trot matrix is the parameter alpha. After that, we have to define the transformation matrix between the third link and the basement, multiplying the previous matrix we defined. And now what we have to do is to save the first 3 components of the first column of the matrix inside a column vector P, and then we have to save the first, second and third component of the vector P inside row vectors P1, P2 and P3, which represent the x, y and z coordinates of the end effector in a certain position. So the y variable is used to change the position of these vectors. We can close all the force cycle, and we can represent the workspace of the robot along the xy plane and xz plane. Now let's talk about the Jacobian matrix, a matrix used to calculate the velocity of the end effector using this equation. So the velocity of the end effector is equal to the product between the Jacobian matrix and the velocity vector of the joint of the robots. As first, we have to define a joint variable vector q, which represent the configuration in which we want to calculate the Jacobian matrix. For example, 0, p, half p, minus p, 0. And in order to define the Jacobian matrix, we can use the command Jacob-n or Jacob-e in order to calculate the matrix respect the end effector coordinate system, or Jacob 0 in order to calculate the matrix respect to the basement coordinate system. Then we have to use the robot variable kr and the vector we had just defined. Let's find the simulation. Let's run the simulation. And this is the Jacobian matrix calculated in this configuration. Moreover, the Jacobian matrix is used to find the so-called singularity configuration, particular configurations which reduce the mobility of the robot and reduce the rank of the Jacobian matrix. In this configuration, the rank of the matrix J is equal to 5, which is the maximum rank of the matrix. And if we consider a possible singularity configuration, for example the rest configuration, where all joint variables are 0 and the joint axes are parallel to one another, we can also plot this configuration. This is the Jacobian matrix calculated in this configuration, and if we calculate its rank, we notice that this time it's equal to 4, so it is minor than the previous configuration, and it means that this configuration is a singularity configuration. Well, this is all for today. I invite you to subscribe on my channel and see you for the next video.